Hello, and welcome to the Sessions on Technical Tips. I am Dr. Monica Tyagi, Application Scientist at Biotechnic. Today, I'll be talking about the basics of method development for icIEF fractionation on Maurice platform. MauriceFlex is the newest addition to the Maurice portfolio that runs icIEF fractionation on a new fractionation cartridge. The fractionation method development is easy and based on regular Maurice icIEF method. You can run your existing icIEF and CESDS assays as identical to Maurice, and there is no need for method revalidation. There is no change to the software platform. It runs on the Compass for Ice as all the Maurice family members. It is well understood that the modifications from chemical or enzymatic reactions during the production and storage processes of the protein therapeutics lead to form the charge isoforms. The charge variance is a critical quality attribute in biotherapeutics requiring thorough analysis to ensure product integrity. Shown on this slide is an image icIEF picture of an antibody, mosunetuzumab. Antibodies like these are typically analyzed for their main peak, and then to the left you can see the acidic species, and to the right of the main peak are the basic species. In here, there are listed post-translational modifications which are known to induce both acidic and basic charge changes for the mAbs. Let's take a look at the fractionation workflow. We begin with injecting the sample, followed by the focusing step. After focusing, then there is a mobilization step to bring your peaks closer to the end of the capillary. And finally, collection of the samples. After fractionation, we perform a verification check on a classical icIEF cartridge. This is because we want to compare it to the similar conditions as the fractionation sample and to check our peaks have been collected in the wells. The collected fractions can be further utilized for downstream analysis, such as for intact mass, subunit mass using mass spectrometry. The initial fractionation run takes around 4 to 5 hours, but the subsequent runs can take less time by optimizing the collection and the verification steps based on your previous runs. To learn more about the new faster verification method on our MauriceFlex platform, please scan the QR code below. Here, I would like to take some time and talk more about the chemical mobilization. Let's check out this video. Load the samples in the capillary of the Flex cartridge. Once your protein samples are loaded, the electric field is applied to create a pH gradient within the capillary, and proteins with different pI values, they migrate along the capillary until they reach their matching pH. Now, during the chemical mobilization, the acetate ions from the mobilizer solution, they enters the capillary to displace the hydroxy ions when a voltage is applied. And this results in the change of the local pH, and the protein charge variants become positively charged. The positively charged protein moves toward the cathodic end of the capillary and eventually out capillary into the mobilizing solution. And then all these fractions are collected. As I said, ammonium acetate, which is the mobilizer solution, it enters into the capillary when the voltage is applied, and then the pH will change, and the protein charge variance will become positively charged. Only the charged molecules are then moved through the capillary to bring them closer to the end of the capillary, and just before eluting them out, one by one, as you saw in the video, and they are dispensed into the 96 well plates. To have pure fractions, only charged molecules are collected. Therefore, fractions, they do not contain any of your solubilizers, say as urea or methylcellulose, as they are not the charged molecules. Each fraction, once eluted out of the capillary, one by one, it is dispensed, as I said, in the 96 plate. And the fractions, they can be further, either they can be collected and individually used for downstream analysis, or they can be pooled further if required in a higher concentration. If we take a closer look inside the MauriceFlex, those of you who are familiar with Maurice will find that MauriceFlex is very similar, except for the additional adapter that will be required to hold your 96 well plate and the reagent while when using the fractionation cartridge. If you are working on your regular icIEF or CSDS applications, you won't need to use the adapter. You will be working on your MauriceFlex platform as you do on your regular Maurice. For your icIEF fractionation method development, it starts with the previously developed Maurice icIEF method, and you'll typically only need to optimize a few parameters from there. For many molecules, adding an additional 20 millimolar arginine to the final sample with the separation mix it's used for your Maurice icIEF method provides sufficient fractionation performance, and it don't need further development. But for more challenging molecules that do not fractionate well or have limited solubility, for those I'll further discuss method optimization and the different steps as shown in the workflow chart. This is how your plate and reagent setup look like when running a fractionation application. You can see the reagents and the 96 well plate setup. These samples are placed in the A row, and the remaining rows are assigned for the fractionation collection. The bulk reagents, such as your methylcellulose, fluorescence, calibration standard, water, catalyte, mobilizer, they are your bulk reagents and they are placed in the glass vials. What are the key steps in method optimization? This requires an optimized icIEF profile and focusing parameters. You need to have an optimized sample concentration and the optimized fractionation parameters. I will be talking in more details about each one of these steps. This is the comparison of a profile of a map on the analytical icIEF cartridge at 0.25 mg per mil concentration, which you can see on the left, and on the fractionation cartridge at 1 mg per mil, that's on your right. The fractionation profile should have the same number of peaks as the analytical profile. This is where you lock in your icIEF method. We recommend starting with 1 mg per mil concentration of your sample for fractionation. Further increasing the efficiency of each flex run by increasing the sample concentration, it might allow the higher concentration of each fractions collected in the individual run. However, additional optimization can be required due to sample aggregation and high current. The increased sample concentration concurrently elevates the formulation buffer concentration, and sample with initially lower protein concentration and higher salt formulation will induce higher current, and this increases Joule heating and sample aggregation, leading to issues with focusing or mobilization steps. So we need to be thoughtful and vigilant when we are increasing the sample concentration. So here is an example of a USP map where the samples with initially lower protein concentration and a higher salt formulation and their impact on the current. You can see that there is a high current because of the high salt. There is increased Joule heating and sample aggregation to lead to issues such as in focusing or mobilizing. And at the end, here you can see at the end the fraction check, there is a loss seen in the acidic species. So high current from high salt buffer, it can lead to fraction loss and precipitation. So how can we resolve this issue? So for the USP map, what we have seen that by desalting, the maximum current seen during the focusing was 2.5 times less for the desalted sample at 1 mg per mil. And that way we can help and optimize our further sample concentration. Coming to the next parameter, how to optimize the focusing profile. The goal is to have all the peaks of the sample and the PI markers within the optical window, as you can see on the electropherogram on your left. And the initial current is below 90 microamp. And as we discussed earlier, for this, we need to be sure about the salt concentration in our samples. So how can we ensure that all peaks are visible and they are within the optical window? So for this, we recommend adding an additional 20 millimolar arginine to the method is developed on your Maurice icIEF. And that's what you'll be going to use for your MauriceFlex icIEF fractionation. Now, due to the longer separation length of the capillary for a icIEF fractionation cartridge compared to the Maurice icIEF cartridge, the additional arginine must be added to the sample as the cathodic blocker to focus the peak within the cartridge optical window. Now, increasing the arginine concentration if the basic PI marker is not visible. You can also adjust the arginine concentration as needed if the pH gradient is formed within the capillary suboptimal. Now, if we look at the figure, you can see the effect of adding an additional 20 millimolar arginine to the prepared sample for MauriceFlex CIF method. The NIST MAB, it was run using the Maurice CIF sample solution at zero point 0.2 mg per mil on your icIEF cartridge. Then add zero point 0.5 mg per mil on the icIEF fractionation cartridge and at zero point 0.5 mg per mil using the Maurice icIEF sample solution with 20 millimolar arginine on the icIEF fractionation cartridge. As you can see, the addition of 20 millimolar arginine to the sample solution, it results in the basic PI marker, that's your 10.17, being visible in the icIEF fractionation cartridge optical window. How can we further improve the resolution of our profile? The default focusing method might not result in a fully focused profile at the end of the separation of some of the molecules. Now, in these cases, you can decrease the focus period time from 3 to 10 minutes and add an additional focusing step as needed to ramp up slowly. We recommend starting with 5-minute increments at 2000 volt for a focus period 4 up to maximum of 10 minutes. This approach, it minimizes the diffusion and the effect of electroosmotic flow on focusing when using a icIEF fractionation cartridge. Proteins do tend to aggregate. Some molecules may show evidence of precipitation or aggregation during the focusing step of MauriceFlex batch due to the higher sample concentration, typically that is used compared to your Maurice icIEF batches. If you have sufficient peak intensity but observe an unexpected peak profile, say aggregation spikes, you can either reduce the sample concentration or add protein solubilizers to the sample. When optimizing the sample concentration to verify the peak profile, it's important to avoid artifacts caused by signal saturation. Signal saturation can be identified by peak shape that flatten near their maxima and may distort the peak profile or reduce resolution between the peaks. Peak intensity should be below 60,000 fluorescence units to avoid signal saturation. While Maurice Flex batches are not meant for assessing peak quantitation or resolution, the number of peaks should be comparable to those seen on Maurice icIEF batch used for the same molecules. Urea, a common solubilizer, it can be reconstituted with the 0.5% methyl cellulose instead of water for ability to accommodate additional concentration amounts. And there are other solubilizers that can be individually tested or they can be used in combination. Moving on to the optimizing the fraction parameters, and that includes the two steps. First, the mobilization step, that is to move the sample peak closer to the end of the capillary, as you can see in the figure A on the top. And the fractionation step, that is to collect the fractions of the mobilized variant in the 96 well plate. Analyzing the mobilization time, if sample peaks are not collected in the fractions and the sample peak is visible after the 25 minutes of mobilization, then increase the mobilization time. You can adjust the mobilization time as per the sample profile. Say, for example, when samples containing the urea, samples typically mobilize slower during the mobilization and the fractionation step. This could be the result of the lower current after applying voltage to the samples containing urea. We recommend increasing the mobilization time to 35 minutes to ensure that the desired charge variants are close to the capillary end when starting the fractionation steps. So once we have successfully collected our peaks of interest, and now we would like to focus on the purity of each fraction that we have collected. In order to increase the purity of each fraction, we recommend reducing the fraction collection time. Now, reducing the fraction collection time, as you can see here in the figure, which is on your left from 45 seconds to the figure on the right, which is 25 seconds, we could improve the purity of this charge variant based on our Maurice icIEF result. The B2 and the B1 peak for the NIST map were collected with increased purity using the 25-second fraction collection time, as verified when running the fractions on the Maurice icIEF using the 40-second fluorescence exposure. Charge variant percent purity is shown to represent the different fractions. However, for some molecule, reducing the fraction collection time won't help or improve the purity in the fractions. Adding a refocusing step to the fractionation batch, it allows for refocusing the samples after the mobilization step and before the fractionation step. Sample profile can be affected by the mobilization in the capillary during fractionation and leading to multiple peaks being collected in the same fraction and decreased purity. Refocusing during the icIEF fractionation can improve peak purity in fractions. Running fractions for a mAb on Maurice icIEF at 20-second fluorescent exposure showed better charge variant peak purity when using refocusing versus without refocusing. The percent purity is shown for most of the abundant charge variants in the representative fractions in the figure below. Those were the key steps that need to be considered when optimizing your MauriceFlex fractionation run. However, some molecules might need further optimization steps. That could be using an alternative mobilizing buffers. There are other mass spec friendly mobilizers that can help with better fraction stability. Sample storage and stability can influence the choice of mobilizer. Most importantly, only the cationic buffer should be used as the non-cationic buffers will migrate into the capillary. Please do refer to the resources highlighted on the slides, which include app notes on various applications such as intact mass analysis, subunit mass analysis, SPR binding assays, and peptide mapping using flex fractionation on MauriceFlex platform. I'll take a moment and would like to highlight some of the interesting molecules that we have studied and did the method transfer from icIEF cartridge to the Maurice Flex fractionation cartridge. Here is an example of a bispecific antibody. And again, it was an easy transfer method. As you can see here on the left side, there's an innovator molecule and the biosimilar molecule on the icIEF cartridge at a concentration of 0.1 mg per mil. And then the method was transferred onto the flex fractionation cartridge at a concentration of 2 mg per mil. And it was an easy method transfer. Here's another example where fractionation on MauriceFlex icIEF platform enabled isolation of charge-separated AAV capsid protein species VP1, VP2, and VP3 for downstream LCMS analysis. This approach had addressed a key limitation of traditional icIEF, lack of peak identity, by allowing direct collection and characterization of individual charge variants, thereby confirming capsid protein identity and supporting assessment of heterogeneity and post-translational modification. Please do, I would highly recommend to refer to the QR code and look into the article that we published. Here is an example of another mAb, Herceptin, a monoclonal antibody that targets the HER2 receptor, inhibiting the downstream signaling and activating the immune-mediated cytotoxicity, indicated for HER2 positive breast and gastric cancer. Here, we successfully did the method optimization for fractionation using the standard ammonium acetate as the mobilizer buffer. As you can see here on the figure on your left, it shows the mobilization of the peak, and on the right, the overlay of all the fractions that were collected. Here is another molecule of interest, an antibody drug conjugate Kadcyla, a microtubule inhibitor. Here we show on the left, you can see the mobilization of the molecule towards the end of the capillary, followed by the overlay of the fractions for the fraction check. Here again, ammonium acetate was used as the mobilizing solution. For more details, please do refer to our recent webinar on ADC fractionation. So here's what MauriceFlex can do for you. You can have your charge variance fractionated using the MauriceFlex. It's an easy method transfer from Maurice Analytic icIEF to MauriceFlex fractionation. Modification to the analytic method, focusing time and the mobilization can be made for specific samples to increase efficiency. Fractionations allow for extended characterization, process monitoring, and downstream analysis of therapeutic proteins. For more details, please make use of these resources. And if you have any questions, please reach out to us. Thank you.